Today we are going to talk about our last lesson for this unit, which is referencing Cpctc. Today I'm going to be using some highlighters, so I just showed those on the screen. If you want to pause and grab those, you can do that now. Okay, so how do we use Cpctc? Well, the phrase itself is something we want to think about in general. So what does it stand for? It stands for corresponding parts of congruent triangles are congruent. Okay, so Cpctc. And this is a term that is used in all parts of math. So it's not like I made up this acronym or Sumner itself. It is an acronym all in itself for math. So you would see this phrase on the internet or anywhere else that you go to learn math. So Cpctc, which is corresponding parts for congruent triangles are congruent, which is going to be an important tool that you're going to be using when you're talking about congruent triangles. Now, you can never use Cpctc as the reason to establish that two triangles are congruent, but you can use it afterwards once you've proven that a triangle is congruent, okay? So again, you can use this after you've proven a pair of triangles is congruent. Importantly, after, okay? It cannot be used as the reason two triangles are congruent, but you can use it after. Okay, so when you're proving triangles congruence, you'll be able to use all your shortcuts that we've talked about before. But what are the important things we want to talk about in reference to Cpctc? Well, again, you must always prove two triangles are congruent beforehand. And you may never use it as a reason for why two triangles are congruent, okay? And if both those things are true, then if Cpctc is used as a reason, the statement is either going to be two segments are congruent or two angles are congruent, okay? Because again, we've already proven the triangles are congruent from one of the shortcuts. If we're using Cpctc, we are saying that there are other corresponding parts of those congruent triangles that are also congruent. So things that may not have already been given or that we can see visually through vertical angles or reflexive property. Okay? So in summary, if a reason and a proof is Cpctc, it is used after a pair of triangles are congruent. Okay. So what we're going to do here is we're going to prove the following information, prove the following parts are true given the congruency marks that are provided to us. So we are not actually given any information in these. We are only told what we are trying to prove. Okay, we only know what we're trying to prove. Now, to say that we weren't given anything is not necessarily true. We are told things by our markings, but it wasn't written out for us. So that's part of the lesson today is noticing when things are congruent based on markings. So to make sure we have that skill down pat. So let's look at the first one. So what I want you to do is take a second and look at what is provided to you. Sorry about that. Look at what is provided to you with the markings and write them down. So I'm going to give you a couple minutes. Now I'm obviously going to pause my video and unpause it here. But what I want you to do is pause it, try it, and then check back in once I reveal the answer. Okay, so let's talk about what you should have seen now. You could have seen these things in different orders, but as long as you saw these things, then you're good to go. And there were three things that you could have seen. So the first one I noticed was that JL, segment JL, is congruent to segment ML. Okay, and I'm going to use my colors to help make sure we match up what is true. Then we have MN, segment NN is congruent to segment JK. Again, using a color to help us see that a little bit clearer visually, as well as making sure we know what matches up with each other. And then the last thing that we could see is that we have congruent angles, and we have congruent angles here and here. So angle J is congruent with angle M. Like so. And all that was given to us, okay? So all the given is going in one box. From here, we want to see, do we have enough information to prove our triangles are congruent, or do I need any more information? And in this case, I have 3 pieces of information. I have a side, an angle, and a side. So therefore, I can prove these triangles are congruent. Now, when you list your triangles are congruent, you want to make sure that you list them in corresponding parts in the same order. So if I start as down here at KJL for my first triangle, then my next triangle should be, pause for dramatic effect, NML. And again, we said we had side, angle, side. Green, orange, blue, side, angle, side. Now that I've proven that I have 2 congruent triangles, or a pair of congruent triangles, I can prove anything else on this triangle is congruent as long as it's in corresponding parts. Again, corresponding parts of congruent triangles are congruent. Now, obviously, we already know this piece of information. So now we want to see this. So this is JLK and MLN. So this is what we're trying to compare. Now, to clarify, this is not vertical angles because that's not how the image looks like. But we can say that JLK is congruent to angle MLN because of corresponding parts of congruent triangles are congruent. Cpctc. So to clarify, since the triangles are congruent, then all corresponding parts are congruent. So I could also say that KL and NL are congruent. I could also say that angle K and angle N are congruent. I could list any of those and still say Cpctc because I already know the triangle is congruent and I already know the other 3 pieces of information. So anything else not listed would still be congruent as long as they're in corresponding parts. Okay, but we're done with that one. Okay, so again, we're going to have you pause and try number 2 and find all these statements that are given to us. Again, there are 3. And one hint before you go, on here we have some markings for T and V. Don't just say that they are congruent, state what we know about the image because those are congruent. And that's my hint, and I'll clarify that in a second. Okay, let's see what you guys came up with. So first thing I noticed is that we have some congruent sides. So now when we look at this, make sure that you notice that these triangles are kind of, one is kind of upright and one is upside down. So when you're using your letters, make sure that you are coordinating with the corresponding parts. So if I were to say RS is congruent, I'm not going to say RV because that's a different way of looking at it. So in real life, it should be UR. Okay. RS, we're starting at the top to the bottom, and in this case, this is the top of the triangle, and that would be the bottom. Then the next thing I have is another set of congruent parts. So I'm going to say RT is congruent to UV. Okay, and then the hint before you left was I said that we want to think about not only are those angles congruent, but what about the fact that they're congruent does that tell me? Oop. Okay, so we know that these are 90-degree triangles, or sorry, 90-degree angles. Okay, and when they're 90-degree angles, we know 90-degree angles are all congruent to each other. Okay, but what does that tell me about the image itself or about the triangles themselves? Hopefully you thought about the fact that that means that these images are right triangles. So therefore, what I want to state in my statement is that triangle RTS and triangle UVR are right triangles. Okay. Now, because we know these two sides are congruent and because we know these are right triangles, can I prove that the triangles are congruent? Yes, we can, because we have enough information. We have two sides and we have an angle, but in particular, we have a 90-degree angle, which means that these are right triangles, which means this would be considered a hypotenuse, the RS and the UR. So therefore, we're looking at hypotenuse leg. So therefore, I can say that these triangles, and I'm going to throw in a change here. Let's try it out. TRS. What would be the appropriate order for the other one if the first one was TRS? Hopefully you said VUR, and that's by hypotenuse leg. Now again, once you've proven the triangles are congruent, you can prove anything else is congruent as long as it's corresponding. And in this case, we want to prove that TS is congruent to VR, and we can prove that by Cpctc. Okay, so again, anytime you're talking about hypotenuse leg, you always have to make sure that you talk about them being right triangles, okay? Not just simply about the right angles themselves, but that they are right triangles anytime you're using hypotenuse leg. And again, we're focusing on that Cpctc, which really just adds one extra step on all the proofs that we've done so far. Okay. So that is it for notes. That is all you have for notes. So you should have a quality amount of time to do your assignment. Which you should use that time. And I'm just going to show a little preview of that assignment here. Okay, so on these first one, they are given what you are trying to prove. And in this first one, you're given a table, which is more what you should be used to with what we've been doing. But down here, you are given just open T charts. And you have to kind of figure out how much do you need to put in order to prove it. Well, to help you out, we're going to tell you how many steps, okay? Since we're still getting to that point. So on number 1, obviously you have 4 steps. On 2, you have 4 steps. On 3, you have 5 steps. On number 4, you have 4 steps. On number 5, you have 3 steps. And then on number 6, you have 4 steps. So anywhere between 3 and 5 steps, most commonly 4 steps. But you have quality amount of time. So once you're done with this video, go ahead and grab the assignment and use your time wisely to get this assignment done. Bye.